Hi there and welcome to a new lesson in which we are going to be talking about player controller types. What we really have to understand first are the two main types of controllers that you may be able to create in games. So the first type that we can identify is a platformer controller. This is the one that you may find in games such as Mario Bros, in which the player has gravity, so it is always going down if it's not on the floor, so there is a force. And the player can also jump. Okay, so that's the two main characteristics. So in this case, the player can move right, left. Okay, it can never actually go down. In reality, what it has is a force. Okay, and the same thing with going up. It cannot kind of move up. It can just apply a force which would create the jump. You will see why this is important in a second. Now in top down, this is usually found in games such as Stardew Valley, basically RPG games, or games in which basically they are not platformers. Okay, of course I'm talking about 2D games in this case. So this is just the opposite. This has no gravity and it has no jumping. This video is part of my full 10-hour Godot course just released in mid-May 2025. Every day new students are joining and leveling up their Godot skills, and you can too. Want to learn more? Click in the description down below. At all. So in this case, the player can move down, right, up and left. And as you can see, there are no kind of external forces involved. There is no jumping, there is no going down, etc. It is just this. For this specific type of game that we want to create, what we need to create is a top-down controller, okay? We don't really need any kind of gravity or jumping. I just want to have basically a player. Let's say that this is the player and that there are some coins. Let's say that these ones are coins. Okay, and like this. Okay, I just want to allow the player to move in every single direction and go ahead and collect the coins. That's why we're going to be using a top-down controller and not, for example, a platformer controller, because we are not going to be having any kinds of platform, okay, or anything like that. So here we have a platform, here we would have the player, let's say, and we are not going to be having a level in which I know the player jumps around some platforms and collects coins, in whose case, once again, the player would be able to move left, right, and also because of forces, up by jumping and down because of gravity. This would be the equivalent to a platformer controller type. Okay, so once again, with all these drawings, I believe it's quite easy to understand why, but it's pretty important for us to identify the differences to be able to code our movements, okay, because they are set very differently. So what we have to do in order to start doing this is to use a script. So really make sure that you are on the character body, that this is the node highlighted, and press on this button, which as you can see says attach a new script. So let's click it. Then you may also have a template, and I believe that actually by default this has the character body to the basic movement template. So this is a pre-made template by Godot developers to have a 2D basic movement. And you think, oh okay, I don't have to code. In this case, what happens is that this character controller is not of the type of controller that we want. Actually, this type of controller is for a platformer controller. I will actually create it with that template just for you to see this. And that's why I took the time to explain this in the past lesson. Because if you don't know this difference of controllers, and you go to Godot and you see, oh, here there's a basic movement template, I don't have to code, you may think that this is correct, but in reality it's not what we want. Once again, I will just leave it here as basic movement, but in reality we are going to be starting from an empty script. We also have some other templates, such as a node template, which as you can see, it just have some functions that are already written in the script. This is not something that we're going to be using either. We're going to be seeing functions as the course goes by. And then we have the empty template, okay, which is the one that I'm used to using the most. But Once again, I will just create it with a basic movement script for you to see this thing of the controllers. Then built-in script, this is a more advanced topic which we don't want to cover in this course unless we have the path. So let's basically change the path because right now we would be saving to the scenes folder and that doesn't make any sense. So with this button, you can go to the parent folder. So basically we'll be going back. And here with this button, once again, let's create it, scripts, and open and check that the path is correct and then press create. As you can see here at the top, you also have some options, or well, you can basically change between the different options, or well, the different environments that the Godot engine provides. You can go to the 2D mode, which is the one that we have been on. We also have the 3D mode, which right now, as you can see, has nothing. Okay, and you can move around holding down the right click, by the way, but we are not going to have anything in this game in specific. We also have the script tab, the game tab, which is the one that is going to be activated once we press play to start the game. And lastly, Godot also have an asset library. Basically, you can also get here some images, some tools, etc. Once again, something that we want to be using in this course. So, of course, I believe that if you have never coded before, reading all this can be a little bit complicated to understand. But trust me that with the knowledge that we have done with the first lessons of this section, you're going to be able to understand this much easier. So first of all, what we have here is a new line that says extends character body to D. Okay, so this basically means if you don't like the word extends, maybe a more technical but easier word to understand with this is that it inherits from character body to D. Okay, so this basically determines which object is the parent of this script. If you don't have this line, okay, if you just delete it, the script is not going to work. Okay, as you can see, we are starting to have lots of errors. So once again, we can press Ctrl Z of Zebra to go back and everything is going to be perfect. Now, the first two things that we find over here are constant. We'll actually have a specific lesson on constants, okay, in a few lessons, okay? So right now I don't want to go too technical. What we can just think of this is as these are values, okay? So speed is equal to this, jump velocity is equal to this. And then these values are just used in different places inside of the code. So for example, speed is used over here and jump velocity is used over here where we are handling the jump. Once again, we'll get in a second into this logic. Now, what we have over here is the physics process function. And what exactly is this? This is a function that, well, it's not technically correct to say this, but just for you to understand, it's a function that is called all the time. Okay, so all the time, Godot is executing the lines that are inside of this function. Also check how here this code has tabs, okay, over here. So how exactly do you add a tab? By pressing the tab key on your keyboard. So everything that has one tab is inside of this function. And also you can see that in the conditionals, okay, if not is on floor at the gravity, here it's saying that, well, you also have your own tabs over here to tell Godot, hey, this line over here is part of both this physics process function and this condition over here. But once again, we're going to get this in a second. What I want you to understand about the physics process is that it is called all the time. How can we validate this? If we put our mouse cursor over there, as you can see here, I have my blinking cursor. We press enter, we add a new line and Godot automatically indents it. If we type print, parentheses, and between those symbols, we type hello, for example, and then here at the top, we press on this button, which will run the current scene, and we wait a second, we're going to see that here all the time, this basically determines the messages that we have in the output. And as you can see, we have here hundreds of hello messages. Okay, here's how you can validate that it is printing all the time something. It's being executed all the time. Now, we also have a delta parameter. I am not going to be covering delta right now, at least in this lesson. So I'm going to skip it, as well as the thing that here says float, here void, this symbol over here. We're going to be able to understand this in a few lessons. And let me just explain you the first lines here that are the easiest ones. And then in the next lesson, we will get to understand these last ones. So first of all, here this adds the gravity. So these lines are quite easy to understand. Here they are checking if we are not on the floor, okay, basically if we are floating, apply the gravity. So in this case, what happens, let's say that we have here Mario Bros. So right now Mario is not on the floor, so this force here, gravity, should be applied. If Mario is on the floor right here, gravity should not be applied because we are right now on the floor, on the ground, okay? So that is basically what is going on. Now, how exactly the velocity is applied could be a little bit more complicated to understand at this point. Basically, the velocity, once again, if we put the mouse cursor over there, here it tells us current velocity vector in pixels per second. It doesn't matter pixels per second, we don't mind about the units here. What we mind is that this is the current velocity of the object itself. So what happens is that we can think of this as a formula, okay, right now. If we take our velocity and we add to it, okay, the gravity that our, let's say, imaginary world has, and we multiply this by delta, which is this is called the parameter, we apply gravity. Right now, that's all that you have to understand. Then we'll get more, we'll basically dig deeper and you will understand this even more. If you're interested in what get gravity does, you should be able to put your mouse over here and you should be able to read what it does. It just returns the gravity vector computed from all sources. Well, it tells you lots of things, but it is basically just the default gravity that a Godot project has. So like this, we add the gravity if we are not on the floor. And let's say that the formula to apply gravity is this one. Now to handle the jump, first of all, you have a condition, but this condition has two conditions. Firstly, if input is action, just press UI accept. UI accept, we can actually see it. We can go to project settings, input map, and show built-in actions. Here we find UI accept, which is basically the enter and the space of the keyboard. So this condition is going to be true when we press the space or the enter, basically when we would want to jump. Now, we only want to jump if not only we press the corresponding key, but also we are on the floor. So once again, coming back to this example, here the player is on the floor, so here the player should be able to jump. However, in this other example, Mario is not on the floor, it's in the air. So in this case, Mario should not be able to jump because it wouldn't make sense, of course. Once it reaches the ground, well, it should be able to jump again. And how exactly do we apply the jump? Once again, you can see a similarity with adding the gravity. In this case, we just make it equal to the jump velocity. In this case, we just take the velocity.y because we just want to move vertically. Why do here we use velocity and not velocity.y if when we apply the gravity, we may think that we are only moving down? If we just try to make this velocity .y, as you can see here, it tells us invalid operand float and vector 2 for assignment operator. I don't want to get too technical into this, but what you have to understand is that our velocity, as you can see, it's a vector 2, okay? And what vector 2 have, okay, they basically have an x value and the y value, as in maths. So that is why these are a vector 2. And what happens is that get gravity is a vector 2, okay? Because for some reason here, Godot calculates it as a vector 2. So not only is gravity a y value, which would be like the normal logic, but it also contains an x value. So that's why we cannot directly tell Godot to modify velocity.y, because it's not possible. If we say velocity equals a vector, okay, it doesn't make sense, because Godot doesn't know how to assign that. This side of the formula has to return the same type of data that this other formula returns. Here we are talking about a vector, and here we are also talking about a vector, as you can see. But if we go to a part of the vector, of one of the components to the vector, then we are trying to assign a float, okay, which is for example 1.2, and we're trying here to assign a vector which contains an x and a y. So that's why we are receiving this error, because this doesn't make sense. You thinking that's in real life, can you assign to a 1.2 an x and a y value? No, you can't. You can either assign x or y, but you can't assign both at the same time. That's basically what is going on. By the way, you can press on here and, well, it's going to be expanded. So what you have here is a variable. This is once again just a value that is stored, and this value, okay, this variable value is actually made equal to this expression, input of the get axis UI left, UI right. What does this mean exactly? If we hover on get axis, what this has is basically a negative action and a positive action. Now, the best way to understand this is to just add a print statement and here print the direction that here we have stored, okay? So let's run the current sim, and you can see we are getting here the value, and if we press the right arrow and we keep it down, we find 1. If we don't press anything, 0, and if we are pressing down left, we find -1. That's basically what this is doing, and this is just related to the direction to which we want to move. Now, as in maths, if we want to move right, we have to increase the x. So this is basically what we are doing. In this case, direction is just 1, so it's going to move right, as you can see, just 1 unit, which is like super small. Or if we press left, it's going to be -1, so it's going to move left. Sorry, if we press the left arrow, it's going to move left. So with this, you can understand how the direction is being calculated. Now, here it says if direction something else, something else. Now, what the if direction means, the best thing to understand this is to add once again more print, and to, for example, print here if direction, and to print here, once again, bear in mind the syntax, it has to be in the exact same way, else direction, for example. You can modify here the message that you want to print, but the rest of the syntax must be the same. Just for you to understand when when we are inside of this condition and when we are inside of this other condition. So, sorry, I pressed the wrong button. We have to press this one. As you can see, now we are in else direction. If I don't press anything, I am on else direction. I am basically right now in this place over here. Now, if I start to hold down either left or right, I get the if direction. So what does this mean? Because the code is maybe complicated to understand at first for a beginner. If direction means if we are moving, okay? Whereas else in this case will mean if we are not moving. Now, to be more specific, okay, maybe you are not able to understand what is going on. Once again, if and else work as in real life. If this condition is true, this code is executed. Else says, okay, if this condition is not true, if we are not moving in this case, just do this other thing. So, in reality, if direction, which means is that this input dot get axis, this is actually a float. As we have seen, it returns 0.0, 1.0, or -1.0. And if you check, if you say if float, in this case if direction, what you're checking for, if direction, is that if this direction is different from 0. This operator is that is not equal to 0. And here, if you are checking for not direction, so this else, what it's actually doing, is just saying not direction. Once again, this is pretty complicated language to understand. So remember here, if we are moving, it means that direction has a value, okay? Or it has a value different than 0. Whereas here we're checking for if direction is equal to something, okay? Which in this case is going to be 0. Why did I use double symbol here? To assign a value, as we have done over here, we just use one symbol. But to compare if a value is equal to another one, we use double symbol. It's just a syntax. If you wanted to do it like this, it's not going to be able to compile to work, basically. And right now, once again, let me just add quickly the same print. So if, and this would be, let's say, the else. And let's run the game. We have else if I am not pressing anything, and if I press the left or right key, as you can see, I do get the corresponding ifs. Once again, this is just for you to understand what is actually going on. And lastly, we have move and slide. What it basically happens over here is that we're modifying this velocity, which, as you can see, is basically just a property of the character body to the node. So what basically happens is that the player is not going to move around unless we call move and slide. So it's basically this velocity is not going to be applied unless we call move and slide. If you actually delete this function over here and we run the code, the play is going to be frozen as if this code didn't exist, basically. That's just for you to understand this move and slide. And lastly, how exactly here we're applying the movement. The direction we have already explained. Direction returns 0, 1, or -1. So now that we do have the direction, just moving using velocity.x is quite simple. We just say direction times speed, which is just another float over here. Y times speed. Remember, direction is just 1 or -1 when we are moving. So we would just be moving 1 unit every frame, and that will be super slow. You can even check it out. By the way, with F6 you can quickly run the current scene, which is the same button that we are using. That's the shortcut. So in reality here, let me quickly show you how I move. So as you can see, I am pressing left and right keys, and the player is not literally moving anything. Okay, because it's moving in such small units that it's not even moving. I will press Ctrl Z to go back, and now I will press the right keys, and as you can see, it is actually moving. In reality, if you don't multiply by speed, it is moving, but it's just moving at 1 unit a time. Whereas if we multiplied it, in this case by its speed, it's 300 units. So it's much more, it's much higher. Okay, so that's why it's being multiplied by speed. Once again, right now you don't have to understand exactly why this works, how it works, because it's vector math. So it will be a little bit complicated for you to understand this at first. So at first you can just think of this as a formula. Whenever you want to move stuff, you always have to multiply a direction times a certain speed. Now, if we are not moving, what this move towards does, if we hover over here, this basically returns a certain float. So this is going to do a calculation and assign it to velocity.x. So basically, it will take a from value, a to, and a delta, which is basically the speed at which this is going to happen. So if we take velocity.x as our from value, basically as our beginning and final value, we take the velocity and we make it 0, it is just going to deaccelerate linearly. That's basically what it's doing. Instead of just stopping and making velocity 0, it's making the accelerate over time. In reality, you won't really find a lot of differences if you just make this 0, okay? We will actually see this in a second. Now, why this was important and why I wanted to explain you this, because now you have gained a lot of knowledge in terms of code. You are going to be learning even more knowledge, and we will dig into more advanced topics as the course goes by. And now what you can also spot here is the fact that Godot told us this was a basic movement template, but it was in reality a basic movement template of a platformer movement template, and we want actually a top down, because here, as you can see, the player goes down and we don't want that. What I will super quickly show you is this platform movement working. Now that we understand the logic, we at least want to have the player moving around. So what I will actually do is create a new scene. Once again, I will do this super fastly, just as a showcase for you. You don't have to follow along. I just want to show you how the controller currently works. So what I did here is to create some kinds of main scene in which I put there the player scene and also just a platform here. Once again, this is related to what I explained here. We had the player scene inside of the main scene. This process is called instantiating a scene inside of each other. Okay, once again, we will get into explaining this in some of the lessons, but basically here I have the player scene, the same thing that we had over here, and I just added a static body 2D, a sprite, and the collision. Why static body? Because remember, this is a type of collision object, okay, that basically doesn't move. This is useful for walls, platforms, etc. Why not a character body? Because we are not going to be moving this with the script as we are doing with the player. We don't want a rigid body because we are not going to be having any kind of physics. We don't want this wall to be bouncing around or anything like that. We just want it to be static. And we don't want an area 2D because this is not a physics object, as you can see. So if we actually created this as an area, the player would just trespass it. So if we now run this scene, let me first just save it. Once again, you don't have to follow along with this. There we have the player, and Well, we can move around, as you can see, with left and right, and with the spacebar we can jump. But once again, this is not the type of controller that we want for this specific game, but I also wanted to show you how you can create it with the template and understand the code better, etc. And lastly, to understand even more collision objects and all that, what you can do is to right click on the static body, change type and make it an area, just so that you see what is changing. Now when we play, it is just trespassed. What happened there is that, okay, the area did detect, okay, that there was a collision with the player, but it was not a solid object. Another way of thinking about this is that the nodes that you have inside of physics bodies, these are physics objects. Objects that, let's say, have a mass. So they have like a body itself. That's why they are called bodies. And that's why they interact physically with each other. They can make them stop from falling down, for example, as with a static body. But the area is not a physics object, so it is just a trigger in that manner. It is just an object that can detect collisions with other objects, but it cannot have any kind of physics behavior, or it cannot have an impact on the physics behavior of any other object. Once again, this is a pretty complex topic, but I believe that now you have a very interesting basics about this, and you're going to be learning more about this throughout the course. So just if you wanted to follow along with this, I will show you how to delete these things. So we'll close that sim, go to the scenes folder and just delete this sim. And there it is, okay? And we are back to where we used to be. And in this one, I'm going to be changing the controller type. Now remember, this code does work, it is perfect. We have been able to understand it even more. Now the problem with this is that it is not of the type that we want. Because basically here, as this player controller has gravity and jumping, it is more similar to what we find in Mario Bros, for example. But in the case of our game, in this game specifically, we don't want it to be like this. We want it to be more like a top-down game, in which the player doesn't have gravity, and also the player cannot jump. It just moves up, down, left, right, etc. So once again, now thanks to this, what we can do is quickly go to the sections in the code which do gravity, which apply the gravity and allow the player to jump, and delete those. So once again, you can see how everything that we have seen in those first lessons that were maybe a little bit complicated start to connect. So let's go back here to Godot, and remember, we have to delete the code to add the gravity and to handle the jump. And we basically have it over here. Add the gravity, so we don't want any kind of gravity, and we don't want to be able to jump. Here we go. Now we also have this line highlighted in yellow. Why is that? We can press over here to read about this. Basically, Godot is telling us that the parameter delta is never used in the function. So it also tells us that if this is intended, prefix it with an underscore. So basically here we are not using delta anymore. We were using it. Let me press Ctrl Z of Zero to go back. We are using it here to apply the gravity. We are not using it anymore, so we can avoid it. Okay, and therefore, if we don't want this warning, we can just add the underscore. And now, as you can see, we just have the code to move left and right. Okay. Now, what is the problem with this? If we run this scene, we can move indeed left and right. We have no gravity, but we cannot move up and down. And this makes complete sense. Remember that technically, okay, in a platformer type of controller, the player cannot move up and down. It can just move left or right. That's basically what just happened. We can just move left or right, because previously the y-axis, basically the vertical axis, the up and down of the player, was just handled by the gravity, in this case the up down, and the up direction was handled by the jump. But now we don't have neither of this, so we have to make the player go up or down also according to the input. Now, how exactly do we do that? So the way in which we're going to be doing is the following. We'll still use a direction, but here, instead of just getting an axis, what we're going to be doing is that we're going to use a vector. Get vector is super similar to the axis, but remember that. Let me also just add here input.getAxis just for us to see it. GetAxis just gets a negative action and a positive action, okay? But in this case, getVector has a positive and negative actions for two axes, for the x-axis, okay, and for the y-axis, as you can see. So this is what actually is going to allow us to move around, because we want to be getting the complete direction, up, down, left, right, okay, not just left and right. So, and here we have the different negative x, positive x, negative y, positive y. Remember that these are all input actions that we have to provide. If we go to project settings, and well, we go to project settings, input map, and we show built-in actions, because these actions by default they are hidden, they already come with the Godot project. We find these different actions. In reality, we can find UI left, UI right, UI up, UI down. Then we'll replace them with our own custom actions, but to start off, it is completely fine. So these are quite simple. These are just called when, for example, we press the right, up, down, and for up, where is it? UI, sorry, here we have left, right, up, and down. It's perfectly fine. So taking into account this, we first have to provide the negative x, and the negative x will be UI left, as we have seen. What do we have next? The positive x. In this case, is going to be UI right. Then, what do we have? We have the negative y. Now, in Godot, the negative y, you may think that it would be UI down, because in maths, when you go down in the y-axis, the value gets decreased. Once again, I will super quickly, just in case you don't remember this or whatever, I will quickly explain it over here. So here you have your axis. Oops. So here you have it. And well, what you have is that, well, here, this is the y-axis, this is the x-axis, and what you have here are different values. So you may have here, for example, 0, 1, 1, 2, and 3, and here -1, -2, -3. Okay, so this is like the normal logic in maths in the y-axis, and this is the same logic as we have in Godot. Now in normal math, what we have also in the y is 3, 2, 1, and when we go down, it's -1, -2, and -3. But in Godot, this is actually inverted. So these values are, to go up, it's minus, 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 and to go up, sorry, and to go down, it's actually positive. So it's just the opposite as in real life. Once again, I will just make this be negatives in the y-axis, and these ones are positives. Okay, once again, the opposite to real life, to logic. You can also validate this by going to the player, and if you want to move your player, if you set the y position to be -10, as you can see, the player has moved up. If you set this to a positive value, it moves down. So therefore, the negative y is not going to be down, it's going to be up. Okay, once again, the opposite. Sorry, UI up. Okay. And lastly, for the positive y, well, as I have told you, the positive in the real life logic would be up. It's the opposite of it, which is UI down, because of the different things that I have already explained. And with this, you already have the direction explained. Now, I will then go ahead and explain what this column is doing over here. Right now, we don't need it, and I don't want to explain it neither right now, but I will explain it very, very soon. So now, we do have the direction. Now, what is going on is that we are just modifying here the x velocity. But right now, remember that the velocity is a vector 2. Okay, you can check it over here. But in reality, here we want to move in x and y. So we will directly modify the velocity itself. Okay, and here, when moving towards 0, okay, I will just do it like this. But in this case, let's just not do the acceleration at all. Let's just do it like this. Okay, so I can also delete the line with Control X. I select the line, for example, this one, Control X, I delete it. And with just 3 lines of code, here we have the controller. Let's run it. And when I press the arrows, as you can see, I can move around. And now we have the corresponding type of controller. Now, if you want to see this direction, we can print it. So print direction. And now we can even see how the vector changes. If I move just right, it is 1 in the x. Left is -1 in the x. Going down is 1 in the y. This is what I told you. This is the completely opposite to the normal logic. And going up is actually negative. Okay? And we can even move diagonally. Okay? As you can see. It's 0.7 for a mathematical fact to avoid moving faster diagonally. We're not going to dig deeper into that. Let's just look at the symbols. Okay? Okay, and here you can validate what you have learned with the things of the axis, positives, negatives, etc.